Well, the story starts with the Iceland, which is which you see here, and we have records of ice conditions 1200 years back, actually, from the Icelandic sagas. And here we have Iceland, and here we can see that the ice disappeared year 800 after Christ, and it was almost ice-free up to 1200, and then we had the Little Ice Age with a lot of ice, and then it disappeared. And when the ice disappeared around 800, the people in Norway sailed across and occupied Iceland. It was crowded in Norway at the time, so they immigrated to Iceland. And it was during the Viking time they had this kind of Viking ships. And a little bit later there was a Viking called Eric the Red, and he was had a very tough temperament, and he killed his neighbor in a dispute, and he was sentenced to what do you call it in English? Anybody could kill him if they wanted to, and there were people who wanted to. So he was afraid to hang around, so he took his ship and a few people with him, his wife. She agreed to come with him on the condition that he built her a church. And they sailed over to Greenland, which they had heard about existed, but nobody had been there. They had seen it from distance before. And in the southern part of Greenland they found a nice suitable place to settle, where they had sheep and they could graze, and it was possible to live there. And here's still the ruins of the church that he built for his wife, Tjodhilde. And after 5 years he was then off the hook, and he sailed back to Iceland and made one of the largest PR stunts in history, talking about the green land and how fruitful it was and so on. And he had 25 ships sailing with him back to permanently occupy Greenland. Unfortunately, they hit a bad storm and 9 of the ships went down, but 14 ships made it, and they set up 2 settlements, the eastern settlement and the western settlement, that's the southern part of Greenland. Then the year 1203, the ice came back, and what happened? Polar bears came ashore on Iceland, which was not happening too often, but that was a signal of something happening. And actually only 3 years ago same thing happened. Polar bears came ashore on Iceland, and they were fairly quickly shot. They didn't like polar bears walking around threatening their sheep on Iceland these days. And then we know that during the Little Ice Age there was a lot of ice. The settlements in Greenland, they disappeared around 1350. The main reason was that there was so much ice that there was no communication back with Norway. The bishop in Trondheim, which in those days were called Nidaros, he had regular communication with the people on Greenland, but that was broken because of the ice. And the conditions for grazing sheep and everything got worse and worse. So they probably, we don't know for sure, but they probably got into their ships and sailed south. And they landed Newfoundland. We knew they had a repair shop for ships there. We found remnants of the Viking having a settlement there. But then they probably sailed a little bit further south, but they hit Indian territory. And the Indians didn't like the new settlers and took care of them. So we don't know really what happened. But in the year 1868, a Swedish famous explorer, Adolf Erik Nordenskiöld, he had done a couple of expeditions to Spitsbergen from 1958, 61, 64, and then in 1868 he could use a Swedish postal steamer that was ice strengthened for winter traffic between Sweden and Germany across the Baltic. And he sailed north and into the ice, and he reached the furthest north ever made by a ship for 81 degrees 43 minutes or something like that. That was of course an interesting thing, but on their way back a storm blew up and the ice made a dent in the hull next to the engine room. Water poured in and almost took out the fire in the boiler, and it was very critical because if the boiler went cold they had no steam for the pumps, so we just managed to keep the pumps going to keep the ship floating until they managed to fix the hole in the side, but they made it and came back home safe. If you move forward to 1881, there was an American Arctic expedition under command of DeLong, and he was north of Siberia with his ship Jeannette, and it got stuck in the ice and crushed, and the crew made it over the ice ashore. Some of them didn't make it, but half dozen or so made it and were found by the Russians and sent back to the US. But what happened was that a piece of wreckage from the ship showed up on West Greenland a couple of years later, and that showed that what's in the ice around eastern North Siberia drifted across the Arctic Ocean, and that gave Fridtjof Nansen, a famous Norwegian explorer and oceanographer, to use that discovery that the ice is moving across the North Pole. So he managed to get financing by the government and built a ship built to be frozen into the ice, and the hull is shaped like this, so when the ice was pushing the ship would pop up and not get crushed. But it was extremely strongly built by Colin Archer, so that they had 1 meter thick oak walls in it and big beams across. So I don't think the ice would be able to crush it either. But the idea was successful, and Fridtjof Nansen sailed along the Siberian coast to the New Siberian Islands and let it freeze into the ice and drifted north. And after 2 years he was sure that the drift wouldn't take him to the North Pole. So he got off the ship with Hjalmar Johansson on skis, and they skied north trying to reach the North Pole, but after 6 weeks or so they figured out they wouldn't make it because it was too rough. So they turned around and skied southwest, and they made it to Fram in the ice, and Nansen and Johansson, they made it to Franz Josef land. They got ashore on Rudolph Island, and they set up a little camp here to spend the winter. And their camp is this pile of rocks you see here. They were down in the ground, and they had seal skins and walrus skins as cover over this big log, which is still there. So they managed to survive the winter, and they used the same sleeping bag to keep warm. And then the next spring they continued to Cap Flora, where they met the Harmsworth-Jackson expedition, and they were taken back to Tromsø and arrived to Tromsø the day before the ship Fram arrived to Tromsø. And the Fram came out of the ice north of Spitsbergen and sailed south to Virgo Bay, where a Swedish balloonist was waiting for southerly wind to fly to the North Pole. This was 1896. And there was a kind of competition who would get first to the North Pole. Andre with his balloon, or Fridtjof Nansen with his ship. And there were a lot of cartoons made of this kind of thing. And Andre's theory was that why mess around in the ice when you can fly above it. But the problem was that there wasn't that much southerly wind. So that whole year there was never southerly wind. They had to give up and sail home and come back the next year. And they came back a little bit earlier and caught the day with the southerly wind. And there were 3 men on the expedition. One of them was a young scientist who was the official photographer. He designed the camera that had a lot of special features. Here we can see it. It had exchangeable lenses, exchangeable cassettes for film or glass plates. It could also have stereo lenses for stereo photography. It had a leveler, so it could keep a constant 15 degrees down for aerial photography, etc., etc. So we could say it's the prototype for the current Hasselblad camera. And the 11th of July he sailed off from the northern part of Spitsbergen, and here we see the first aerial observation of the Arctic ice pack taken from the balloon after takeoff. So it's quite a unique picture I managed to dig out. After 3 days they lost enough hydrogen, and there was also ice on the balloon, so it got heavy, and they had to abandon the flight at 83 degrees something, and they started struggling, dragging their equipment and a tiny boat over the ice. Here we see the route, sailing a bit north with the southerly wind, and then the wind turned easterly, and then it turned northwesterly, and then they had lost enough gas so they went down, and then they walked in a southeasterly direction for 3 weeks. Then they discovered they hadn't gotten anywhere because the drift was against them all the time. So then they changed direction, going more south, and they figured out that the ice is drifting faster than they can walk. So they settled the camp on the ice, just sitting there waiting. The Crystal Palace they called their home. And the ice flow took them drifting around White Island, which is here, and they drifted here. Strangely enough, they drifted around, and they could make it to shore on the only tiny spot here where there was no ice. This whole island was covered by ice cap, and it's one tiny place here you could go ashore. And that's what they did. But we know from finding their diaries, in 1930, 33 years later, the camp was found. We only knew that they disappeared, etc. But 33 years later, a Norwegian sealer went ashore. It was a unique year with very, very little ice. And that's why nobody earlier who passed this place didn't see the camp, because it was snow and ice covered. But this year, a lot of the ice disappeared, and the camp was visible. And they found the 3 bodies, the diaries, the camera, the films, which has then been developed, which you saw just a few pictures of. And yes, now I have to read myself here. It was published in an American paper. The Arctic Ocean is warming up, icebergs are growing scarcer, and in some places the seals are finding the water too hot. All point to a radical change in climate conditions and hitherto unheard of temperatures in the Arctic zone. Exploration expeditions report that scarcely any ice has been met with as far north as 81 degrees 29 minutes. Great masses of ice have been replaced by moraines of earth and stones. The report continued, while at many points well-known glaciers have entirely disappeared. When was this? Was it last year, or when was it?
50 years ago.
Pardon me?
50 years ago.
You're getting closer. U.S. Weather Bureau, 1922. So we had a warm period in the 20s and 30s where the ice diminished, but that seems to have been forgotten. But there were, of course, a lot of ice observations from sealing boats, fishing boats up in the Arctic, and but they were not systematic, so it was difficult to get the whole picture. But this was what you read here. It was partly reported by the Norwegian Council, and he had reports from the fishermen and the sealers. But then we started being more effective traveling in the Arctic, and in 1926 Amundsen, he set off with an Italian-built airship named Norge, which means Norway in Norwegian, built by Umberto Nobile in Italy, and was purchased by the Norwegian Flying Society. And he made a flight from Norway to Spitsbergen and then across the North Pole and to Alaska, and they ditched the airship in Teller, Alaska. And they were all extremely tired after 3 days of flying, no sleep. They had hallucinations at that stage. And here we see the airship coming out of the hangar at Kings Bay, where they started the flight. And on the 12th of May 1926 they crossed over the North Pole, which you see on this picture. And you see there are open leads here and there in the ice. And that is always the case. It's more or less open water in the summertime, and wind directions and currents play with the ice, and sometimes it's big leads, sometimes smaller leads, and so on. And but also at this time regular flights started to happen in the Arctic, and this shows this this Australian Hubert Wilkins and Ben Ailson. They flew a Lockheed Vega from Alaska across the Canadian Arctic, across the north of Greenland, over to Spitsbergen, and they landed in a snowstorm on Spitsbergen and later made it down with the ship back to Norway. And the Russians were quite frequent flyers up there, flying up from Moscow, Arkhangelsk, up over the Arctic, and a few flights that made it over to California. And Levanovsky was one of them, but he disappeared. But a few others, Shaklov and others, they made it to Vancouver, Oregon, and San Jacinto in California. But then the more systematic flights started with my old friend Einar Sverre Pedersen. He became chief navigator of Scandinavian Airlines from day one, and his dream was to fly from Europe to America and Asia over the pole, which is the shortest route. So he started developing navigational aids to do that. You can't fly on a compass, but a combination of a gyro, which you see on the picture here, that Bendix developed for him, and with a kind of telescope where you pinpoint a star which has a radio signal, so you can track with that radio signal a position. And he made a separate charts called the polar grid, and then they could navigate straight over the Arctic. And here we see the Scandinavian flight over the North Pole, and this picture is from 1957. I don't have a date, but it's a lot of open water, as we can see on the picture. And then also a lot of ice observation was, of course, done by ice islands. The Americans, actually the Russians were the first already in 1937. Papanin was leader for a station set up at the very North Pole. The Russians flew in 4 planes, landed on the ice and set up the station. And they drifted, but in a few months they drifted out of the Arctic and had to be rescued. But the Americans found a a piece of an ice shelf from the Ellesmere ice shelf, which is 300 feet thick or something. And it was a safe platform. So in 1952, the US Air Force landed on the ice here, set ashore, on the ice 3 men to prepare runways so other airplanes could land and set up a proper base. And this place was called T3. And it drifted for about 25 years around and around the Arctic. And you can hardly see a station there, and you can see a little piece of the runway on the ice. And in 1967, I was in Alaska on my honeymoon trip, staying with Einar Peterson, the navigator. And I was invited by the head of the Arctic Research Laboratory in Point Barrow to visit them. And when I was there, they walked up to me suddenly and said, "Do you want to come on aboard a flight to T3?" "Sure," I said. So they pushed me into this plane, the DC-3, and we took off and we flew about 4 hours straight north and landed on the runway there. It was minus 35 centigrades. It was pretty cold, but I was prepared for it, except my camera wasn't very prepared for it. I have a short video. I keep keeping the batteries warm for my, well, not a video camera, film camera, and I had a tough time keeping the batteries warm enough to move the film, but I have a short film too. And we landed, kept the engines going for about 20 minutes, and unloading and taking on board the station manager who was retiring that day, and off we went back to Point Barrow. But it was quite exciting to have visited this place for 20 minutes. Then we come into a new phase of Arctic exploration and ice observation, and now from 1958 we could start to study the ice from the other side, from the bottom up. So they had sonars on the nuclear submarine. The first one is, as you remember, Nautilus, 1958, under Commander Anderson. And they didn't surface at the North Pole on the first trip. The first submarine to do that was a submarine called Skate. But in 2005, there was a New York Times reporter on a tourist cruise on a Russian icebreaker that went up to the North Pole, and when it was there was open water. So he thought he did a scoop by reporting that all the ice has disappeared in the Arctic due to global warming. So he really heated up the debate, and this news was of course spread around the world, which annoyed us people who know what's really going on. And it's nothing unusual that you have open water, like a small lake even, at the North Pole in the summertime. And here we can see the nuclear sub Skate surfacing at the North Pole, and there's not much ice on this picture. And the polar bear, of course, wonders where did the ice go? Instead, another sub popped up, the Queenfish, whose captain is a friend of mine. And then at one time there were two American and one British sub having a meeting at the North Pole. So this is the kind of open water in summer, midsummer, you will see at the North Pole. Nothing unusual, nothing to report about, really. But the most systematic observations of the Arctic ice started with the satellites in 1979. And the beauty of the satellite is both for being able to map the ice situation, but also they started to measure global temperatures in a more objective way using satellites, because they measure not only land surfaces but also ocean surfaces at the right proportions. Today, when you measure global temperatures with thermometers, 90% are on land, and land is only 30% of the Earth's surface. So you get a very bad imbalance and errors because of that, of course. Well, now I have to go down and sneak here. Well, I started looking at has the ice diminished or not over the years. And I picked up the first picture of the Arctic ice from November 1979. That was the first recorded. And you can see the extent. And then I took one 24 years later. And it's hard to see the difference, isn't it? And this is the month of November. But it's also important to know that the maximum ice in the Arctic is usually in the month of March, sometimes in April, normally in March, which we see on the left picture. And the minimum extent of ice is in September, end of September. And here we can see that it was 15.5 million square kilometers winter, 6.2 in the summer. This means that it is normal that 60% of the ice melts every year. So it's quite a big change from winter to summer. This is normal, but that is never spoken, that it is normal that 60% disappears every year and recovers then in the winter. Then we had the 24th of September 2007. We had an extreme year with little ice, they say, and this helped to fuel the climate debate, of course. But it's misleading, because what happened this year was that there were extreme strong winds and currents pushing the ice from this area across to Greenland and Canada. So the amount of ice was not that drastically less, it was just the ice extent that was less. But that is never pointed out. And the next year, the minimum ice level is quite much more, you can see. But that has also another explanation, and that is a change of ocean currents, which I'll come back to. In 2009, the Alfred Wegener Institute in Germany, they have this DC-3 slightly converted to turboprop and things. It's named Polar 5 is the name. And it took up and it flew up to Spitsbergen, where it landed, and then it continued to the actual North Pole, where it calibrated its instrument, because here they could drill a hole in the ice to see how thick it was and compare it to their measurements from the ice radar they had. Then they flew across to Canada and around the Arctic and came back. And they were quite shocked to see the results. The results showed that the ice thickness had increased 1 meter over most of the Arctic. In 1 year it was 1 meter thicker. But that, of course, was not convenient to tell the world. So it was not spoken much about. But I happened to see a small note. I contacted these people when I was preparing my paper, and they were not reluctant. They were a little bit reluctant to talk about it, but I got some data and some published papers they had, but they were not too keen to discuss it. They didn't want to get in trouble with their bosses. And so here we can see what happened to 2007, 2008, 2009. The ice is increasing. So something happened in 2008. And we will see soon what it was. Also, here we can see what happened in 2012. It was extremely little ice in that year. So that also fueled the climate global warming debate. It was extremely little ice that year. But what you never heard anybody say was that 1 month later, after the minimum, it was twice as much ice in the Arctic in 1 month. That has never been recorded before. That's a very rapid increase, which is interesting. And here we see, let's see, what was the point here? Yeah, this is 6th September, October 2003. Well, this is a more normal increase. That's a comparison with 2003. It only increased a little bit, 20%. That's more normal, not 100%. Well, this shows us the temperature, world global temperature. You're familiar with this curve, I suppose. Oops. And we see that in the 1800s it was colder than average over a certain period. And then 1910 something happened and the temperature started to go up. And we see the ice situation in the 20s and 30s happened during this here. Then something happened in 1940 and we came into a colder period. And the people who like to scare politicians to get money, they claimed that we were heading into a new ice age. And you can see here Time magazine, the big freeze in 1977. Another issue, how to survive the coming ice age. I used to tell my friends back home that they should buy property on the island of Malta in the Mediterranean. They would probably do well, but they have to wait 4,000 years until the ice is coming. And here we can see that in 1977 something happened and the ice started to decrease. And here in 2008 it turned around. So something happened here too. But most of these alarmist scientists, they ignore this. The diagram stopped at 2007. And I asked at the meeting the professor, I told her, you know, how much has the ice decreased since April last year? This was in 2009. And she blushed and she said, well, it has actually increased. And I said, well, I'm sorry, but you told us a moment ago that it is decreasing at an accelerating pace. What's going on here? And she said, well, that was maybe not completely up to date what I said. She said, well, I thought we came here to be updated to this meeting. So the whole audience began to understand there was something fishy going on. So I think I converted about 200 people who didn't know what was going on. They began to understand. But what happened? Well, if we look at fairly recent discovery, maybe 15 years ago, people started to be aware of this effect. It's something called Pacific Decadal Oscillation, PDO. And I don't know exactly how they calculate, but they have an index which went from minus to plus in 1910. And let's see if I'm right here. Yes, and then it was positive index to 1940. It went negative. And then in 77 it went positive. So those dates I pointed out obviously have a connection with this ocean current. And when PDO is positive, the ocean current is going, the warm water is going up along the American coast. And actually a lot of water goes up through Bering Strait into the Arctic. And when the current reverses, becomes negative, the current goes the other way and no warm water goes into the Arctic. And here we can see that from here there is a strong current of warm water coming up here and circling around. We also have the Gulf Stream we all know about coming up here. And it goes up the coast of Spitsbergen, and it usually doesn't freeze the west coast of Spitsbergen. Some years the warm water goes into the fjords, and the fjords don't freeze, which causes a lot of aggravation for the people up there, because they like to go with their snow scooters across the fjords there and make shortcuts to their cabins. And this last winter, the fjords didn't freeze, which they didn't like. But the Gulf Stream here is often claimed to stop and so on, but it can't stop for a very simple reason. The forces bringing the Gulf Stream up here is the Coriolis effect. It's a natural force because of the Earth's rotation. So to stop the Gulf Stream, we have to stop the rotation of the Earth, and I wouldn't bet on that. But what happens is that the Gulf Stream doesn't move on the surface all the way. Sometimes it goes down under the surface, and it's because fresh waters are coming out from the Siberian rivers, coming out here, and fresh water is lighter than salt water. So the warm water goes below the surface and up across the Arctic Ocean. Fridtjof Nansen in 1912 was on Svalbard as an oceanographer, and he discovered at 300 meters depth the warm water. And Papanin at the North Pole discovered in 1937 warm water between 300 and 700 meters depth, which clarifies what happens with the Gulf Stream going up there. Also, we can see in the Bering Strait, in 1975-77, the annual global temperature of Kodiak increased dramatically from 36 to 43 Fahrenheit. And that's quite a lot as an annual average. And in Nome, which is in the middle of the Bering Strait, we see a similar, very dramatic temperature increase. And we can see our alarmic friends, they make a line like this saying that the temperature is increasing in the Arctic. But we see that it was a very rapid increase because of the ocean current, and then it's slowly coming down here, if we want to do a correct analysis. And this is the kind of analysis our alarmist friends make. They see that the temperature is increasing and it's continuing to increase. And you show us this kind of curve with this red line going up like this. And it was similar, almost identical. I made this red line up. But I got a paper last week by Lennart Bengtsson, who is a very well-known climatologist. And he published a paper last year with this basic curve. But then he filled in a line to show the increased temperature. That line is almost identical to my line that he published. And I call myself a climate analyst. I analyze climate data and all kinds of things. And my interpretation of this curve is quite different. It is like this. This is what the curve looks like. It's an upward trend. That's natural to see. But we can see that 1910, 1940, 1977, 2008, we know that PDO in April reversed very quickly. And we can see that it fits in exactly with which direction PDO has. And this is the climate change we can feel. So therefore, you cannot discuss climate change unless you look at a minimum of 60 years, which is the cycle of PDO. Then I often get the question, where does the 60-year cycle come from? Well, we are not 100% sure, but my interpretation is that there is a 60-year cycle in the change of rotation speed of the Earth. Length of day, it's called LOD. We learned in school that one day is 24 hours, but it's actually 24 hours plus minus 200 milliseconds. And that is changing in a 60-year cycle. And the theory is that this change of speed causes the change of direction of the current. Then you wonder, why does the speed of rotation change? Well, the theory is that the sun, this gravity forcing, is causing that. And what we didn't learn in school was that the center point of the sun is not in the middle of the planetary system, like it's drawn up on the chart. It is actually wobbling around the center of gravity, which means that its distance to the Earth is not constant, it's changing with the wobbling. So what is causing the wobbling? Well, that is fairly sure that it is the planet Jupiter, which has a 60-year cycle, which comes closest to the sun every 60 years. It's called perihelion, when it has the closest distance to the Sun. And it's a very large planet, so it has an effect on the Earth. So the 6-year cycle comes from Jupiter planet through the Earth, through the length of day, and through this current. That's how it's hooked together. And many people believe in my theory there. But then when we look at the satellite images showing a constant decrease of ice, it's because, by coincidence, the first satellite observation started at 79, and the turn of PDO was 77. So they have been registering the ice during this 30-year period of warm water flowing into the Arctic. And then we know it's changed, and now it's building up. And also these diagrams showing ocean temperatures show cold water along the California coast and the Canadian coast. This is 75, 76, there's still cold water, the PDO is negative, going that way. And then in 77, it switched and we see warm water building up over the coast. 78, we see warm water up in the Arctic. And then we moved to 2005, it was pretty warm ocean, we can see. And in 2006, it was diminishing slowly. 2007, it was not that much. And in 2008, the cold water came up. And that had a serious effect on the crops in California. So the whole citrus crop was destroyed. And I had a theory that the financial crash in 2008 was due to this. I tested my theory with a very well-known international authority on national economics that I happened to meet on a flight. And he said, to my surprise, it's very possible, he said, because what happened here was that $1.5 billion disappeared when there was no crop to sell. And that triggered off a snowball effect going through the financial system. And you can trigger off a disaster with less money than $1.5 billion. So it could have been the reason. And we know from history that the climate has major effects on our history. Napoleon was beaten not by the Russians but by the climate when he settled around Moscow, for instance. Well, we hear that the temperatures in the Arctic are increasing twice as fast as the rest of the world. And this is also a hoax. Here we see the measurement station at the airport on Svalbard, it's called these days. It used to be called Spitsbergen, but nowadays it's Svalbard. And I got permission and a tag and an escort to come out to document the temperature thing there, which is pretty close to the runway, as you can see. And when I was up there recently, there was a Russian jet flying to the North Pole, standing on the tarmac, blowing its exhaust straight on that box. And the system is that these measurements are made continuously, but the highest and the lowest temperature each day is being saved, and the average temperature for that day, and then every day is added up in a week and a month and a year. But if you have a 40 centigrade registration here as the maximum one day, it triggers off and the whole thing goes off balance, of course. And here we see not an area view because I'm standing on land, but it's an unusual place on Svalbard because I can drive up a hill and I can look down on the airplanes taking off and landing. It's not many places you can do that. And here you see where the temperature is measured just next to the runway. And the more constant area here is not the proximity to the jet engines, but you see that just below the airport is the fjord. And a large part of the year you have open water here. And when that happens, the temperature measured here is 4 centigrades higher than a station 5 kilometers into the valley. But in the winter, when the bay is frozen with ice, covered with ice, the two stations measure the same temperature. So you get an automatic error because of this open water. But this station is, of course, the only one used for the global temperature registrations. If we go to Canada, there's only one station in the Canadian Arctic these days, and it's a station at Eureka, Canada. I have been there, but I don't have a picture with me. And that station is unique. It's called the garden spot of the Arctic because it's very green. And it's a temperature anomaly at this place, where it's growing high grass, and there are rabbits and wolves and muskox and God knows what you find up there. But of all the stations they had 36 stations not so long ago. They closed them down. They only use the one at Eureka because that will give you increased global temperature, of course. My friend Vibjörn Karlén, he studied different temperature stations, and the problem is to avoid stations that measure the urban effect. And that is what you do in most cases. But he filtered out these stations that were probably not too much affected by the urban effect. And we don't see any dramatic increase of temperature here, do we? I can't see it. We see a slight change. What we see is actually the changes 1940, 1977. We can see a tendency of the PDO. And up here it's not very visible. In Tromsø, Akureyri, it's almost gone, the effect, but we see it a little bit further south. We see the PDO effect on the temperatures. Well, one little interesting observation I made is we are back to Adolf Erik Nordenskiöld. He became very famous around the world, being the first to sail through the Northeast Passage, something the British have tried for 300-400 years without succeeding. With the famous ship Vega, whaling ship, he made it through. He made it through in one season, less one day actually. Had 1 day sailing left when they got stuck. And here we see the ship Vega at the northernmost point of the Eurasian continent at Cape Chelyuskin. And with the ship was a steamer Lena, which was carrying coal. So they filled up as much coal they could take. And then the ships departed. Lena went back home, and Vega continued into unknown waters. And the charts were very inaccurate. And when I've seen the original chart they used, and they plotted their course, and it goes half the way over land going east. But they had a small steam sloop that would measure the depth ahead, so they didn't run aground with the ship. So they were checking the depth before they moved forward with Vega. But they didn't make it. Nordenskiöld wanted to go ashore to look at something geological, and the captain and the crew were not very happy. They had 1 day sailing left, and but they spent a day here, and during that day the ice closed in, and they were stuck for the winter. This is the only picture taken of the ship while it's frozen in the ice over the winter. And here we see the map of the course. So that's the Cape Chelyuskin. And here's Pitlikai, where they got stuck. And then they made it through Bering Strait, and they came down to Japan, where they could report the success of having made it through. And they were awarded a lot of presents and things from the emperor, and there was only one big long party all the way back home through Suez Canal and Italy and so on. But why did he make it? Well, he never knew it himself, but I think I'm the first to discover this. In 1878-79, there was a super El Nino we can see on this temperature chart, and that's why he made it through so fairly easily. But of course this super El Nino thing wasn't known in those days. He was just pure lucky. Well, what about the future? What can we tell about the future? Well, I believe we can tell quite a bit about the future. Our Russian friend Habibullah Abdusamatov, who I saw was invited to Las Vegas, which made me happy. He's a very knowledgeable and interesting person. He made up this diagram. Being a solar astrophysicist, he knows all the different cycles of the suns. There are some 6-8 cycles. The shortest one is the 11-year sunspot cycle, the 22-year magnetic cycle, and you have the Goldberg cycle every 87 years. You have a 200-year cycle, 1,000-year cycle, plus minus 500 years, etc., etc. But he added all those cycles together. You see the result, and he says that everything comes back to same level as in the 1600s during the Little Ice Age. And that was when the Thames in London froze every year for 50 years and so on. So this is what we're heading for. Well, fairly recently, the Danish astronomers, following the sunspot, discovered that the sunspot frequency dropped from normal minimum of about 10 sunspots down to 1 sunspot. And it stayed for more or less 2 years. 2007 to 2009, it was no activity on the sun at all. And that was the 200-year cycle that Napoleon experienced when he had very cold conditions. And this is Abdusamatov's latest diagram showing that we are we just passed the peak of the 24 solar cycle. Now we are going down in frequency, and we are going down along this curve. So the next peak, 11 years down the road, will be at the lower level. The next peak at the even lower level. So we have tough conditions coming up, and I think it's important to make it clear for our politicians that this is what we're facing the next 20 years, 30 years, and the harvests will dramatically go down. There will be famine all over the place, and the growing zones will go south about 150 miles, something like that. It will move south, and that will have a major effect on the amount of crops we will get, especially in Russia, because they are on the margin, and they have benefited more than they understand from the warm weather we have had up to 2002 when we had the solar intensity maximum. And so they will suffer badly from the change of the growing zone, and they will be screaming for wheat and other crops. And the other problem, and that's what we are facing today with the problem with Ukraine, is that Ukraine is their main source of crops in Russia, and it's not part of Russia anymore. So the Ukrainian, they can blackmail the Russians to get food. And that's what Putin sees ahead, and he wants to take care of that problem. Yes, there's no problem with the polar bears. They will survive, I guarantee. And this is a funny postcard I found. Sustainable ice breaking. So you have the crew with a piece of something on their head, diving down in front of the ship to break the ice. And here comes the next guy. Let it go up the gangway. Thank you very much for your attention.